Assalamu alaikum. Today we are going to discuss together how to design an MCQ for online engineering exams. First, the contents. We are going to discuss the current problems that we are facing with online unmonitored exams. First of all, the MCQ questions itself and the cheating problem. Then we're going to discuss how to write an MCQ for engineering problems with examples. Then how to bulletproof your exam from cheating. In other words, generating or cloning the MCQ questions. First, let's discuss in the beginning the problem with online unmonitored exams. First of all, problem number one, these are MCQs. For engineering courses, it's difficult, especially for those courses that are dealing with design, to evaluate students' performance or learning outcome based on MCQ. Basically, in our problems, we have sequence of steps that we do or the students will do, and in order to get to the correct answer, there is a chance that there might be a problem or a mistake happened in the beginning, and it carry on all over the problem solving. This way, the student will not be able to have the final correct answer. The second problem is that we are having these exams unmonitored. That means the students can learn from each other the correct answer for a problem. Even if you shovel the questions sequence or shovel the answers, that's still available for students through social media and other communication channels. Okay, so let's first discuss how to write an MCQ questions for engineering problems. First, the objective here is to write the MCQ such that we want to avoid consequential mistakes, to make a quantitative assessment for course learning outcomes partially or collectively. First, we have to divide the problem into small standalone problems. So we don't deal with the whole problem together. No, we divide it into steps and deal with each step or each phase as a standalone problem. We need to minimize the number of operations in each sub-problems, okay, to minimize the chance of consequential errors. For example, let's take this problem. This is from a dynamics, this is a traditional dynamics problem. We have a forklift that is carrying a weight. And if we read the problem here, it says that the forklift showing weights, blah, 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 and is used to lift a crate of weight, blah, blah, blah. The truck is moving to the left at a speed of 10 feet per second. When the brakes are applied on all or four wheels, knowing that the coefficient of static friction between the crate and the fork, that's the crate and the fork, okay, is 0.30. Then what is required? Determine the smallest distance, okay, in which the truck can be brought to a stop, given the following condition. First, if the crate is not to slide, that means this will not be sliding this way. And if the truck is not to tip forward, that means this thing will not flip over the front wheel. Now, we can have this as a one answer, okay, but the steps involved, there's a chance that the students might, do a small mistake here and there. So at the end, he get lost and he will not get to the final answer. This is unfair for the students and it's not a good assessment. So let's analyze this problem. The problem, we need to determine the smallest distance given these conditions. The steps for solving this problem will be by checking the X forces here and to make sure that let me To solve this one, we need to make sure that this crate is stable against horizontal force, that this one is not going to slide, and it's not going to tip over. Okay, and after that we get the minimum acceleration, then we calculate the stopping distance. In other words, let's look deeper into this. There's the first part, to examine the stability of the crate, that it will not slide. Okay, in this part, summation of force, if the x-axis forces will be in this way. This one has 3 steps embedded in it, and here the overturning over the front wheel will be taking the moment around this point. This will involve 5 steps. Then making the selection, maximum deceleration, that's 1 step. Stopping distance calculation using the kinematics equations will be 2 steps. The total steps, 11 steps. Okay. Let's now convert this problem into an MCQ. First, we're going to take the same problem, but what we're going to ask for, determine the maximum deceleration of the forklift such that the crate will not slide. That means we are just evaluating this condition, that this one will not slide, and having the acceleration such that this crate will not slide forward. The second part, okay, the same input, but we are going to say here, determine the maximum deceleration for the forklift such that the truck will not overturn. That means find the deceleration. So that's basically the second part. The third part, okay, the forklift truck shown is moving to the left at that speed. So given the speed and given the deceleration now is an input. Determine the stopping distance for the truck. Notice that here we have 2 steps. In the previous one, we have 5 steps, and here 3 steps. I recommend, but when we assign points to each question, that it should be proportional to the number of steps involved in solving the question. For example, if I'm going to put a grade for this part, I will put 3 marks. Here, I will put 5 marks. Okay, because, or at least to count it for the time. Here will be 2 steps. That means 2 marks. Okay, so that's how we divide. We have shown now how we divided the problem into 3 sub-problems. Now, how to bullet-proofing your exam from cheating. That's very interesting. First of all, simply by cloning the questions. Basically, what I use Excel to randomly generate copies of the MCQ that have totally different numerical values and different answers. So this way, nobody can copy the answer from any other student. How we can do this? Also, we can use large number of choices. In the old days, the standard was to have a 4 choice or 5 choice, because they used to have an answer sheet, a standard answer sheet, and there was a sheet reader. So, now we have computer-based MCQ. So computer-based MCQ, you can put whatever number of choices for the student to select from. In my case, for example, I try I sometimes put 11 choices, and one of them is the correct one. Okay? With a large number of choices, however, you have to be careful not to repeat the correct answer in the distractors, First step, how to generate the clone, or how can we make the cloning of the MCQ? First of all, we have to determine the variables in the problem. So here, for example, we have, that's number 1 variable, number 2, number 3, number 4, which is basically the weight of the crate here, and W2, the weight of the truck, the speed of the truck, and the coefficient of friction. So this one we identify. We go to determine the range of variables. You have to identify a reasonable range for the variables. So I picked for the W1, the range was from 2,000 to 2,800 pounds for the weight of the truck, from 2,000 to 27, the speed from 7 to 12. It has to be somehow related and realistic values. The coefficient of friction instead of 0.3, between 0.25 and 0.35, and so on. So that's the second step. The third step is basically dissecting the text. This text, we're going to dissect it and cut it into pieces, okay? So we can fit it into the Excel spreadsheet later. For example, that's the question, the MCQ 1. Now it's changed to this paragraph. That's text, that's variable. Text, and that's a variable, second variable. Then text, third variable. Text, fourth variable, and text. Now, we will go to Excel to see how we are going to put this all together. The text of the problem. Then we go to the Excel. We are going to start now. We are going now to start populating the Excel spreadsheet with the text for the problem. So we're going to copy the entire problem here. Then this one going to be for variable 1. Variable 1, which appears here, it's W2. Then here going to be text. Sorry. Okay. Don't grab the text. Then here's going to be W1. Okay. So let's cut from this until this point. Okay. Then W2 equal random between 2000 and 2700. That was the range that we determined before. And we go to this text. We don't need this text anymore. And we're going to cut from here, going to the end. We have to copy it first. Here, we're going to say also random equal rand between 2000, 2800. This value is not there. Then we will go to the speed. Speed off. Then here is going to be the speed, which is V. The speed was 10 feet per second, and we determined the range to be something between from 7 to 12. So we can say rand between 7, 12. Remember that the random function will give you an integer value. So you cannot put here fraction. Okay, so if you want, for example, to be 7.5 or 10.5, 10.35, you can put from 70 to 120 and divide it by 10. This is going to be, let's continue the text. The text here will be, okay. Let us just, so that's the text we have. Okay, we're going to keep this text, but we have to make another copy because we're going to need the remaining. Okay, and here we're going to stop just before the coefficient of friction. And here, that's the coefficient of friction. Again, equal random between. This value is fraction. It's the coefficient fraction is 0.3. So again, we're going to put from 25 to 35 divide by 100. Okay. And the units, it's dimensionless because it's a coefficient of friction, and we remove all of this text. Now we have the problem divided into small components. Now, how to get it together? We're going to show you now how to do that. We're going to assemble it together here. There is a very interesting function in Excel, concatenate. Concatenate, basically it joins the contents of cells or a group of cells. For example, it's going to concatenate this one, the cell after, and we have LMNO4. We can just zoom out. Okay, let's go back again. Okay, element OP P4 Q4 4 4 4. That's interesting. Let's see, did we capture all? Okay, we didn't catch the last one. T U4. Determine the let's check the contents. Okay. Okay. Okay, let's read the problem. Readability. Okay, we need to have a space here. So we are going to go back here and just add a space. Enter. It shows up here directly. The rest looks fine. Maybe here we need to have a space after the speed. Okay, I think that's fine. So now we have generated the text of the problem. Now we want to look into the answer, how to get the answer. Okay. Remember that the answer for this problem was to find the the equilibrium for the horizontal forces, for the x-axis forces. So the x-axis forces was in the equation that we had, it was the equilibrium of the crate was governed by this one here. Okay, that the acceleration of this, or deceleration in our case, multiplied with the mass of the crate, resisted by the W1 times 0.3. So that means we're going to say here that it will equal basically W1, okay, divided by, so basically we can say that A1 equals W1 divided by M1 multiply coefficient of friction. Okay, in other words, A1 equal G multiply 0.3, regardless of the weight itself. So that's the correct answer. So this one will equal to 32.2 multiply the coefficient of friction just remove this one. So that's the answer will be here. It's going to equal, or let's put the answer next to the, that's the first answer here, equal coefficient of friction multiply 32.2. Of course, we are working, the problem is in imperial units. So that's why we are multiplying by 32.2. So that's the correct answer. Now, this is going to be one, no feedback. That's the typical alternatives for question mark. Now we want to insert here another fields, okay, to put the distractor or the other answers, okay. So the first distractor here will be this one, the correct answer, plus random between say here we're talking about 0.3, so we're going to add maybe 25 to 55 divided by 10, okay, and this one is not correct. Multiply 0.2. We're going to copy. Make sure that this one is protected. So it's all function of the correct answer. So this way we made 4 distractors. Okay, and remember that this one we are adding on top of these values. Okay, we can just remove this even. We don't need to. we need to add more space for the rest of the distractors. Insert. This one will be the correct answer, but it's minus rand between 25,55 divided by 10. 0, 0. Here, in order to just to make it to look better, make round and 2. You're going to round it to the nearest 2 digits. So that's the second set of distractors which are less than the correct answer. Okay, let's just make this protected. Okay. This way, we have how many answers? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 choices. Okay? So the art of guessing will not work in this problem. Now, that was the first question. Now we need to clone it. Very simple. Take a copy, this line, just copy the entire line. Depends how many clones you want, 30, 40, you name it. Here, now you have the set of clones that you have here. Remember that sometimes you will have some repeated values. Remember, this value, the correct answer is the same like here, but the heading of the problem is totally different, okay? The answers are totally different, and so on. Okay, despite the fact that the correct answer for both problems is the same, but the input for both problems is not the same, okay? Okay, now we want to generate the file that will be imported into question mark. We're going to take this file, copy, then put it here in a separate, and copy, paste it as values. Okay. Then save it as, okay, save it as dynamics 1. And don't save it as Excel. Save it as comma delimited in DOS format. Okay, yes, no problem. Now let's go to question mark to see how. I'm going to add it temporarily to one of my topics. Okay. Here, topics. We go to question mark and open the topics. Then we go to import third-party questions, upload file, browse, go to Here's the file that we saved, Dynamics 1. Okay, we say okay. Fork problem. We generated, by the way, 23 questions. Loading. Okay. That's the fork problem. And these are the questions that we generated. We're going to say display 50. So now we generated 23. Now you have to do some editing to the problem to be, correct. Of course, this way it's not going to look good for the students. We need to put some graphics in it. So we will go back to the main problem and just get the image. Put this one here and copy the image. Okay, we have to save picture as. We go here and we say that we want to upload or add image. Browse to save here picture 1. Open. Okay. The size looks to be a little bit too much, so we're gonna reduce the height and the width to. Okay. So now these are the choices. You have to go here and request shoveling and display horizontal because you have so many choices. So in order to, and also you can change this to be 2 or 3, whatever you give weight for that problem. However, I highly recommend that if you are going to do this, you go at the beginning and between 2 brackets, say 3 points. Some students complain when they have unequal weight for different, and if there's some small typos like this, we can just touch it, then save and exit. Instead of copying the image for each or loading, you can just copy the image, then click save and exit. Go to the next one. Edit that question also. Add here the image, paste, and here save. Then exit. You have to repeat this to the rest of the questions just to make sure that the image of the problem is there. And I hope this will be helpful, and good luck, inshallah. Take care. Assalamu alaikum.